12.1 Introduction to Amino Acid. This is the learning outcomes for 12.1 Introduction to Amino Acids. Amino acid is an organic compound that contains two functional groups, the amino group and carboxyl group. Amino acid commonly found in protein are alpha amino acid. They name as alpha amino acid because an amino group and a carboxyl group is bonded to the same carbon atom. And there are 20 different alpha amino acids commonly found, making up the different polypeptides of protein. This is the general structure of alpha amino acid. As we can see from the structure of alpha amino acid, the amino group and the carboxyl group are attached to the same carbon, which is alpha carbon. The differences of R group, which is the side chain group in each amino acid, will give the unique characteristic of the amino acids. This is the list essential alpha amino acids. All amino acids are optically active molecules except for glycine, because glycine doesn't have chiral carbon. IUPAC nomenclature of alpha amino acid. They are named as amino derivative of carboxylic acid. Look at the example given. We have to find the longest continuous chain that consists of carboxyl and amino groups, and follow the numbering priority from carboxyl group as carbon number 1. After that, name it alphabetically. So the name of this amino acid is 2-amino 4-methyl pentanoic acid. Same for the second example. Find the longest continuous chain, number carboxyl as carbon number 1, and name alphabetically. So this amino acid is 2-amino 3-phenyl propanoic acid. But the IUPAC names are rarely used. They prefer to use the common name. What is meant by Zwitter ion? Zwitter ion is a molecule with an overall charge of 0, which has positively charged group at one part and a negatively charged group at another. Zwitter ion is taken from the German word means dipolar ions. Look at the example given. This is the uncharged structure. So, to form the Zwitter ion, which is dipolar ion, the amino group will protonated to NH3+, which is ammonium ion, and the carboxyl group will deprotonated to form carboxylate ion. To the example, draw the structure of 2-amino pentanoic acid and its Zwitter ion. First of all, we have to draw the structure based on name 2-amino pentanoic acid. After that, we change the amino to ammonium ion and the carboxyl group to carboxylate ion. So, here we go, the Zwitter ion structure. The Zwitter ion will give the dipolar nature of amino acid that give to their unique properties, such as have high melting point, which is generally over 200 degrees Celsius, more soluble in water than in organic solvent. The amino acid is less acidic than most carboxylic acid and less basic than most amines. And they are amphoteric, which can react as acid or base depending on the pH of the solution. Isoelectric point, Pi. isoelectronic point is the pH at which the amino acid exists as sweeter ion, or the structure that has positively charged and negatively charged of amino acid are equal, or the net charge equal to 0. So each amino acid will have their own or specific isoelectric point. For example, the isoelectric point Pi of alanine is pH equal to 6.1. At this pH, alanine exists as sweeter ions. Let's consider the example given. The isoelectric point of valine 2-amino-3-methylbutanoic acid is 6. Predict the structural formula of valine at isoelectric point Pi, pH equal to 12, which is basic medium, and pH equal to 1, which is acidic medium. So how to solve this problem? First of all, we have to draw the structure of alpha amino acid first. After that, we draw the structure of sweeter ion, which is this is also the structure at isoelectric point equal to 6. In pH 1, which is acidic medium, the amino acid will acting as base, which is will accept proton. So the amino group NH2 becomes NH3+. At pH equal to 12, which is basic medium, so the amino acid will acting as acid, which is donate proton. During this time, the carboxyl group COOH turns to COO-. That's all for amino acid. Thank you.